the material derivative and acceleration. So u, where u is the velocity in x direction, this is in Eulerian framework is equal to u x y z t, and v is the velocity component in y direction is equal to v x y z t, and w is w x y z t. Now this point in time delta t moves to another position where coordinates is x plus delta x. Kindly correct it, because of some reason this delta is coming as square. So wherever you see this square, kindly convert into delta. This symbol needs to be converted into this symbol delta, right. So at time t, this was the position vector s, and it was having 3 Cartesian coordinate system and components in x y z direction, which is equal to x y z and time t. Now in time t plus delta t, this point moves to another point where coordinate system is x plus delta x, y plus delta y, and z plus delta z, and time is equal to t plus delta t. So at that time the velocity will become u plus delta u. So u plus delta u may be written as u, this is function of x position, function of y position, function of z position, and time at that point. Similarly, the velocity in y direction will become, this is v, v plus del v is equal to v x plus delta x, y plus delta y, z plus delta z, t plus delta t. Similarly, w plus delta w is the velocity at a point when t is equal to t plus delta t. So w x plus delta x, y plus delta y, z plus delta z, t plus delta t. With the help of Taylor's expansion series, this u plus delta u may be written in terms of the velocity gradient in x y z direction by neglecting the higher order terms. So u plus delta u will become u x y z t. What is u x y z t? U x y z t is the velocity at point when time was t and position of the vector is s, which was x y z. Right, in Cartesian coordinate it was having x component, y component, z component, plus del u over del x, which is the velocity gradient of u in x direction multiplied by delta x, plus del u over del y into delta y, plus del u over del z into delta z, where del u over del z is velocity gradient of u in z direction, del u over del y is velocity gradient of u in y direction, plus del u over del t, partial time derivative of u del u over del t into delta t, plus some higher order term which we are neglecting, right. Similarly, v plus delta v will become v x y z t, velocity at point x y z and time was t. And what is the velocity at time t plus delta t? Is equal to v x y z t plus some more quantities, which is equal to del v over del x into delta x, plus del v over del y into delta y, plus del v over del z into delta z, plus del v over del t into delta t. Similarly, for w component, w plus delta w is equal to w x y z t plus these gradients of w velocity in x, y, z direction, plus time derivative of w, delta w over delta t into delta t. And what happens to delta x and delta y into and delta t? Delta x is equal to u, u is the velocity when time was t. So what happens to delta x? Delta x is equal to distance travelled in time delta t. So what is the distance travelled by that particle which was having u velocity at time t? This is equal to u into delta t, u into delta t. Similarly, what happens to delta y? Delta y is equal to velocity multiplied by time. So delta y is equal to v, v is the velocity in y direction, so v into delta t. Similarly, delta z is equal to distance in the z direction, distance in the z direction is equal to velocity in z direction, which is w, multiplied by time. So, time is equal to delta t. So, w into delta t. Now, if we substitute the value of delta x, delta y, delta z by this concept in the form of u delta t, v delta t and w delta t in these three equations, this equation and this equation, we will get this u x y z t and this u both are same, this u and this u x y z t both are same. So, this will get cancelled and delta u over delta t. So, this delta x will be written as u delta t, delta y may be written as v delta t and delta z may be written as w delta t, and here we have delta t. So, delta t is taken on the left hand side. So, this will become del u over del t is equal to del u over del x and delta x is equal to u delta t. Delta t is taken on the left hand side. So, this will become u. So, the remaining term is u del u over del x plus v del u over del y into delta y. Delta y is equal to v into delta t. Delta t is taken on the left hand side. So, this will become v into del u over del y. So, v into del u over del y, similarly plus w del u over del z plus del u over del t into delta t. So, delta t is gone towards left hand side. So, what is left here? Del u over del t. So, del u over del t. Similarly, del v over del t may be written from the second equation after substituting the value of delta x, delta y, delta z from these three equations. Similarly, from this equation we can write delta w over delta t in the form of velocity gradient in x direction, velocity gradient of w in y direction, velocity gradient of w in z direction plus time derivative of w.